Alrighty, this is another video aimed at characterizing some of the equipment here in the lab. I wanted to look at the signal output from the back of this Rigol DH0924S oscilloscope, which has a built-in signal generator, which would go up to as high as 25 megahertz. And what we're looking at is the output signal from the back. It's being routed through a attenuator, which is currently set to 10 dB of attenuation, and then fed into the tiny SA Ultra. And you can see the 10 megahertz signal showing up here, showing it, not sure, oh, I see, I've got the, it's not actually showing the peak. Let's get it up there at the peak. There it is at the peak at minus 17 dB. So you can control the voltage level, the offset, phase, etc. from the interface. You can also change the type of the wave, sine, ramp, noise, just pure DC, and then arbitrary. I just have it set on sinusoidal. Want to look at just how pure that sinusoidal signal is, and we'll do that by expanding the span of this tiny SA Ultra. Right now its span is only 1 kilohertz, and I have it centered on 10 megahertz. So let's look at that even a little bit tighter with say 1 kilohertz. Let's have a look at just how close to 10 megahertz this signal is centered on. And there it is, showing 9.996. Let's see. There's 10 over there. (9.99999) at minus 17 dB. Let me turn this attenuator to 0. One more scan across. Let's see what it does. Okay. Right, so I wonder if I need to let this unit maybe warm up a bit more. So we've got 1 count off, so that's maybe 10 cycles, something like that. So we've got 5 digits after the decimal point, set at 10 megahertz. And so let's change this, and we'll go from a start of, say, 1 megahertz all the way up to, say, 200 megahertz, and see what the signal looks like out here. So you can see it's pretty much a pure sine wave. We've got nothing at all showing up on the spectrum analyzer down at minus 60 dB. The attenuator is currently at not attenuating the signal at all, and it's showing at minus 7 dB. Yeah, it's at, this is the 10 megahertz still. And let's switch that. This will go all the way up to 25 megahertz. For example, if I type in 30 megahertz, it'll say set at upper limit, 25 megahertz. And let's see what I can get there. Still showing 10 megahertz here. What's going on? Let's see, turn it off and then on again. Is that a bug? Let's turn this off and on again. There's 25 megahertz. That was strange. I'm not sure what happened there. All right, let's switch to, say, 15 megahertz. See what happens. Yeah, it the Tiny SA Ultra immediately switched. It seemed like it might have been something with the Tiny SA Ultra on that prior attempt. Let's do that again. We'll go to 30. It'll say upper limit, going to 25. Okay, and this jumps to 25. And you can see that, yeah, there's no harmonics, nothing showing beyond the pure signal down at minus 60 dBm. So, yeah, we get a pure sinusoidal signal out of this Rigol oscilloscope. If we switch to square wave, let me kick in some attenuation just to be safe, 20 dBs, and go to square wave. There we go. And so now we can see some of the harmonics on that square wave. Yeah, it's a little bit jumping around, not what you kind of would expect as far as the spectrum on that. Let's go to just 100 on the, stop at 100 megahertz. Get a closer look at that. Okay, so there's your 15, your principal, and here's some of the harmonics happening on either side of it. That's what the square wave looks like. Let's go to, back to, let's go to 1 megahertz. That's a little bit more of what we might expect to see. Let's try 5 megahertz. Yeah, that's more in line with what you might expect to see. Oh, I think I know what it is. I don't think the, let's try this again. If I type in 25, I don't think you could go to 25 on a square wave. Yeah, set it upper limit 15. Okay, so at the upper limit of the square wave, you get a maximum of 15 megahertz, and you don't get the expected harmonics. Let's go to 10 again, 10 megahertz. That's a little bit more of what you might expect. There's 10, 20, 30. So the first odd harmonic, right? And we're down at minus 26 dB, and I have 20 dB of attenuation kicked in here on the external attenuator in between the back of this Rigol oscilloscope and the input to the spectrum analyzer. Let's try, let's see, square ramp. Okay, we'll go to ramp. Let's see. And what's it showing there? It's showing 150 kilohertz. Not sure what the limit is here. Let's go to 5 megahertz. Set it upper limit. Okay, it's very low. 150 kilohertz is the upper limit apparently. So actually I have a DC block here which I think is limited to 1 megahertz. So this is not going to work for this particular experiment. So, all right, from the standpoint of just an initial look, 25 megahertz sinusoid between 1 megahertz and 100 megahertz. This is what it looks like. And let's zoom in on that 25 megahertz and just have a look at that. So center at 25. Oops. Center at 25 megahertz. And a span of, say, 10 kilohertz. And there's the signal showing 24.999995 megahertz at minus 29 dB. I'm going to turn off the attenuator. It's going to have to sweep twice across, I think. Yeah. Now we're down at minus 8.8 dBm. Of course, that's all controllable because I've got the amplitude set at 500 millivolts because I don't want to overdrive the spectrum analyzer. So that looks good as far as the accuracy of it, and the purity of the sine wave is very, very good, extremely good. So yeah, once again, we start at 1 megahertz and we go out to 300 megahertz. There's basically nothing beyond the pure signal showing down at almost 65 dBm. All right, that's it for now. Thanks for watching.